What up, Allie Jesse? It's your favorite math teacher. If I'm not your favorite, or maybe I'll get a close second. Um, how's it going? I thought I'd reach out and help you here. You said you were struggling with it and you just learned it, so I don't know. It'll be about 10 minutes if you want to give your time. If not, when was the last time I make you a video? Okay, so what we're doing is we're mixing trigonometry and what we know about that. Hopefully, you know a little bit about that. And the coordinate plane. All right. So what we're doing is we have a circle with a radius of 1. Okay. All right. So we have a circle with a radius of 1. All right. We want to know. Let me get my pen here. We want to know if we made a triangle from the origin going out at 45 or 30 degrees. We're going to do 30 degrees. So we've got a triangle. All right, let me make it a little bit more like 30 degrees. All right, so that's like a 30-degree triangle, and it's made with the x-axis as well. All right, so that's our right triangle, okay? And this is just right angle trigonometry, okay? What we do know is that the hypotenuse is 1. All right, that's a 1. I'm going to have to erase it in just a second. But, you know, it's the radius of your circle still. It's just not going to, it's not going to 1, but it's still going to be 1. It's still going to be a length of 1 because it's the radius of your circle, okay? Okie dokie. Doesn't look like 1 though, but it is. Don't go by what it looks like, you go by what you can prove. So how we're going to do this is, since I know that that's a 30-degree angle, I don't know. Oh, all right. Here, what we're going to do is we want to know what the coordinates of this point are. That's all we're doing right here. And the good thing about this, Jesse, is like they're only going to ask you like 12 questions. All right? It's just a little bit of memorization on your behalf. I don't know if you've done trig identities, but that's just memorization. You know what I mean? So what we're doing is we're figuring out what the coordinates of that ordered pair are. And how we're going to do this is we're going to say this length is going to be your x. I'll do it right here. And then this length here is going to be your y. So here, this is going to make a little bit more sense when I do this. So here's our ordered pair. We just want to figure out what the x is. That's the bottom of our right triangle. And then the side of our right triangle is going to be the y value. Okay? So we're going to do, we know it's 30 degrees. And we know that the hypotenuse is 1. That's all we need to know. That's cosine because it's opposite over, or it's adjacent over the hypotenuse. Because the adjacent side is the yellow one. So we're going to say cosine of 30 degrees is going to be the adjacent, which is, we'll just call it x, okay? Divided by 1, because 1 is the hypotenuse. All right, and to get the x by itself, you multiply both sides by 1, or you don't need to do that. And here's what you get. You're just doing the cosine of 30. All right, that's a calculator question. Let's see. The cosine of 30 is 0.86602, blah, blah, blah. And that's a very familiar decimal, all right? Because I know this just from memorization, 0.866025. I'm going to say, let's do the square root of 2 and divide it by 2. Oh, nope, excuse me. The square root of 3 divided by 2. You get 0.86625, blah, blah, blah. So that is the square root of 3 all over 2. So that's my x value. My y value is going to be the pink one. All right, we're going to call that x, and that's going to be the opposite over the hypotenuse. That's going to be sine of 30 degrees is the opposite, which is x over 1. Or just the sine of 30. Nope, that's not what I wanted. So I'm going to say 30, and that's sine is 0.5 or 1/2, okay? So that's going to be 1/2. That's your ordered pair, okay? And that's all that this is asking you. I mean, if it's what I studied, that's all that it's going to be asking you. You're not going to get any further in depth. I mean, we're going to do 45 and we're going to do 60 as well, or degrees, okay? We want to know the next triangle. Let's do this. We'll do purple. This is going to be 45 degrees, all right? So I'm going to leave the orange one on there, but now we're looking at an angle that's 45 degrees, and we're going to say our ordered pair. I'm not going to do the highlight, but you get the gist. It's going to be the sine, or the cosine of 45 degrees and the sine of 45 degrees. So because that's going to give you your cosine is going to be the adjacent, which is the bottom part of your right triangle, over the hypotenuse. Cosine of 45. That's just going to be the x value for the ordered pair. That's 0.707, and that's a very familiar decimal as well. That is the square root of 2 over 2. All right, you get the same thing, 0.707. So this is the square root of 2 all over 2. This is a private video, by the way. You don't have to worry about everybody in YouTube land like knowing your business. So I just gave you the link. It's private, so no one else knows about it, okay? Just thought that you wouldn't want everybody getting in your business. All right, so we're going to do the sine of 45. Notice what happens here. 45 sine. You get the same thing. So it's the square root of 2 over 2. The square root of 2 over 2. That's your ordered pair. Cool. I'm going to do the next one, which is 60 degrees. And then, as you can imagine, you're going to do the cosine of 60 degrees and the sine of 60 degrees. Oh, cosine of 60. No, that's not what it was. Cosine of 60. That's 1/2. And then you're going to do the sine of 60, which is your opposite over your hypotenuse. So the sine of 60 is that same decimal, 0.866, or the square root of 3 over 2. All right. One of the reasons why I could see why you're confused on this is the numbers are not unique. Like you have the square root of 3 over 2, and then you have the square root of 2 over 2, and then you have 1/2. Like if it'd be one thing if all those numbers were unique, that would just be memorization. It's just a little bit tougher. You know what I mean? That's the square root of 3 over 2. All right. Now, we're going to do the same thing 60 degrees made with the y-axis. And as you can imagine, that would just be, you're going to do the same thing. It's just you're in negative, like you're going to the left. So that bottom part of your right triangle is going to be negative. And you're going to use that same fraction. All right. So if I was going to do 60 degrees, but it's made with the y-axis, you're going to say negative 1/2, and then positive the square root of 3 over 2. Yeah. Now, this is going to be 45. And as you can imagine, that's going to be negative square root of 2 over 2. Square root of 2 over 2. There is one more thing, one more concept that you need to get from this. And that's going to be the square root of negative square root of 3 over 2, 1/2. Now, the other concept that you need to get here is if we are talking about, I almost want to erase this. Those are your ordered pairs going to be all the way around. You're just going to make either the x negative or the y negative, depending on where the ordered pair is ending up. Okay, so I'm going to erase this here, and I want to show you one more concept here. If you remember the formula for the circumference of a circle, it involves pi. And since the radius is 1, it would be, sorry, can't think and do this at the same time. It's kind of late. How's soccer going, Jesse? I guess I can't really get a response from you there. Okay. The other concept, I don't even know if you're going to be assessed on this or not, but you want to know, going around this unit circle, if we know that the circumference is going to be pi r squared, well, the radius, the circumference of a circle, is going to be pi times r squared. Well, the radius is 1, so that's like pi times 1 squared, or just 1. All right, and here's what I'm sorry, just pi. So the circumference of our circle is just pi. So what we could say is that 1 the angle made, if we were going to look at this ordered pair right here, this is like saying pi. So half of the circle is going to be pi, and then the whole thing is going to be 2 pi. I believe it's circumference of a circle. Oh, it's 2 pi r. That's right. That's why that is. Okay, so if I was going to look all the way around my unit circle, all right, that's the circumference. That would be 2 pi r. And I'm sorry, it's not r squared. I'm thinking volume. So the circumference is 2 pi r. So all the way around would just be 2 pi. All right, because the radius is 1. So if I were to go a half turn That's going to be half of 2 pi or pi. And if I were to go a quarter turn, that's pi over, what is that, pi over, that's half, yeah, so that's pi over 2, all right? This would be 3 pi over 2. And then all the way around would be 4 pi over 2 or just 2 pi, okay? So what we did here is the circumference is 2 pi r. Well, that would be all the way around the circle. So if we're going to go halfway around the circle, that would be, let's see, that would be 2 pi over 2 or just pi, okay? Now, if I wanted to look at this ordered pair right here, what would that be in rad? This is like looking at radians. I don't know if you noticed on your calculator here. You have the option. I don't know if this does. You have the option on your other calculator, and I don't have that downloaded on my computer, but on your TI-83, you have the option of talking about degrees or radians, and a radian is talking about, all right, instead of using degrees as your unit of measure, you're going to be using this concept of pi. All right, so you're talking about radians as a different unit of measure. All right. Let me know if you get into this, because the boy that I tutored, I don't think that he did this. I don't think that y'all get into that. I think what I just told you about using the trigonometry, that's the only thing that's going to be on there, I believe. So if not, let me know. And if that you're not understanding that concept, I'll definitely help you out with that. But I'm not going to go into it. I mean, hopefully you understand the logic that's involved there. But Allie Jesse, you're one of my favorite students of all time. If you ever need anything, please holler. All right? Don't struggle with anything. I will help you in any way I can, man. All right. Hope you're doing well. Take it easy.